Thank you very much. So welcome to this session. I hope you had coffee so you don't fall asleep after lunch. And this is a short paper, so I will take you very quickly to what we have done in this short study. The project was run by me supervising Elena on her undergraduate studies. She's graduated last year with a bachelor's degree in computer science at the University of Cyprus. And myself, at the moment, I am at the Open University of Cyprus, the Cyprus Center for Algorithmic Transparency, and I'm also collaborating with a new research center in Cyprus, RISE, which is dealing with emerging technologies, hence the topic of this presentation on analyzing users' task-driven interaction in mixed reality. So most probably you are already familiar with the literature on this topic, on mixed reality. However, just to give you an idea, if you're not, mixed reality deals with combining the real with the virtual content. So we see both at the same time. We can interact in real time with 3D objects that are interacting themselves with the environment, the physical environment. And the motivation behind this study is what we were discussing actually today during the panel before lunch, and what some presenters yesterday and the day before mentioned, that we really need to take into consideration the individual differences of each user. And in these visually demanding environments, like mixed reality environments, this is very important. So we wanted to see whether some differences, cognitive and visual differences that exist between people, whether they affect their interaction in a mixed reality environment. So since this was an undergraduate project and we had limited time, we focused on the construct of field dependent and independent. And for those of you who are not familiar with this construct, a person who is field dependent demonstrates a holistic approach when he or she is processing information, especially visual information, and he or she finds it difficult to extract simple objects from a complex surrounding. A field independent person now, it's the completely opposite. So it's this person follows an analytical way in processing information, especially visual information, as I said before, and finds it very easy to extract concepts that are of interest within a complex surrounding. So this becomes very important for mixed reality interaction design, and this is why we wanted to explore this construct. So what we did, we used Microsoft HoloLens as the device, and we employed the Galaxy Explorer application for two reasons. The Galaxy Explorer application is a very popular one with HoloLens users, and actually it was voted the most wanted application to be developed by HoloLens developers for the public. So we thought that this would be interesting to the participants. And the second reason is that this is an open source application. So we could build a logger within this application to extract interaction data in real time. So that's what we did. We could extract gaze, so where the user looked at, which objects the user looked at in real time, gestures, speech, whatever the user was performing during the interaction. The study, we had 31 subjects, 17 male and 14 female, aged between 20 and 29. And we wanted the participants to have no previous knowledge of this device or the interaction in HoloLens, which was not difficult since this was very expensive. And the device is very expensive, and the average user doesn't have this at home. So we provided training to the basic operations, the gestures that the user needed to perform in order to interact with the environment. And from feedback we got from the users, the training we provided was enough for them to perform the task. Then we needed to see whether the participants were classified as field dependent or field independent. So this is what we wanted to control actually in order to see how their interaction was changing. And in order to do that, we provided the GEFT test, which is a validated test from psychology. It's been around for years. It's a paper and pencil test, so it's not available online. And the scores are from 1 to 18 max. So what do they have to do in this test? They have to pick a simple object within a very complex schema. So we had participants classified from 1 to 17, and the cutoff score was 11, and this is what is used in psychology. So whoever is below 11 is classified as field dependent, and whoever goes 12 to 18 classified as field independent. So overall, we had 20 participants as field independent and 11 participants as field dependent. The task we piloted in order to be able to identify easy, moderate, and difficult levels in this task. So the users had to go in this application and identify objects. So one was Sagittarius A star, Earth, and Uranus. And the difficulty is according to the search behavior, the visual search behavior that the user has to perform in order to identify these objects. Okay, what was our hypothesis? The first one was that there is no interaction effect between the field dependent, independent, and the difficulty level towards the time spent for each user to identify an object. So what we got out as a result is that at the easy and moderate levels, we didn't have any differences between the two. However, when the difficult level came up, the field dependent were much slower in achieving each target object compared to the field independents. And the second hypothesis we had is regarding the objects they viewed before they achieve the target object. So how many objects? So this was basically giving out their strategy. So again, at the easy and moderate levels, we didn't have much difference, but the difficult level was obviously significant differences, statistical significant differences. So, okay, statistics confirm what we basically thought that was the case. However, we had also in-app video recording, so we were able to record the interaction of the users. So we did some observations by analyzing the videos and also observing the users performing the task in a real setting. Both Elena and myself were present during the experiment. So the field dependents, they were very frustrated when they had difficulties. They didn't have a good experience, so the psychological aspect of the user when was interacting was obviously not a good one. However, the field independents were very happy with it. The feedback we got was that, yeah, that was very easy for me, and they took much less time to complete the task and to locate the objects that we requested them. So the results that we got out are aligned with the literature in other environments. So reports that we got from TV, for example, viewing, or 3D environments on desktops and so on. So the results are aligned with the literature. However, we want to run further further tests, and we have already run 3 more studies to examine other aspects of the cognitive abilities of the users and the individual differences when interacting in mixed reality environments. So before I close this presentation, I want to bring this up. Professor Samaras used to be a keynote speaker in 2017 IUI, and he was the person who provided us the HoloLens. We ran the study under his lab. He passed away last July. He was supposed to host UMAP this year in Cyprus, co-chair with George Papadopoulos. However, he's no longer around. Thank you very much, and if you have any questions. Okay.
So the 3 tasks, I mean, they seem very similar. Why did you say they were of different difficulties?
Yeah, the difficulty level was actually how the effort that the user needed to put in identifying, because I don't know if you've used HoloLens and the application. So the planetary system comes in front of you, and you have to actually perform some visual search to locate the object. So Uranus, for example, the difficult object, was located somewhere here, so the user needed actually to navigate in the physical environment in order to be able to identify that object. And before we actually set the difficulty levels, we ran pilot studies. So we had data that confirmed that these were easier, difficult, and moderate levels. Yeah.
What are the design implications of this study? I mean, do you think you can provide some suggestions about more usable applications?
Actually, yeah, in the paper, I didn't have time to discuss it now, but in the paper, we're providing some implications in the design, actually. So this is the motivation of the research anyway. So maybe field dependence, mostly they could benefit from some timely adaptive notifications, for example, because we saw the people searching around and they were making these movements, and it was difficult for them to locate the target object. So maybe if there was something like an arrow or a message or even a vocal thing, a speech or something that would guide them, that would be much better for them. The field independence now, they are usually more fluent in these environments due to their ability. However, they seemed satisfied but uninterested, so maybe challenge them a little bit. But yeah, we need further studies in order to be able to, yeah.
I was just wondering how exactly you were able to track a user's gaze, because from my understanding, the HoloLens doesn't have the capability to like track actual gaze. It just more or less tracks where you're moving your head. So you could have your head stable and you could actually be looking at some other objects that you would miss out if you weren't doing like eye tracking. So I was just wondering.
HoloLens, the way you select objects in HoloLens is through your eye. So you actually, when you look at something, this is what you, is like the mouse, like you use the mouse to select something. This is how you select objects in HoloLens, through your gaze. So you gaze at them and you select them. It's not like eye tracking gaze, so it doesn't give you more semantic information, but it gives you the target object. So the user targets this object, so you can get that out of HoloLens.
Hi, thanks for the presentation. So I was wondering, since your task need users to search and locate some targets,
yes.
So do you measure their spatial ability? You know, how they rotate the image and how they use your
You mean
tool?
the users how rotate or how they rotate themselves?
Yeah, kind of the user's mental ability to rotate objects. Since you asked them to.
Yeah, we actually, one of the tasks for them was to rotate objects through HoloLens or to rotate themselves around?
we call spatial ability. The way the,
Oh
you know,
yeah,
the
no,
orientation
no, we
things.
didn't. Their spatial ability, I mean, themselves to move around. No, we didn't track that. Thank you.